Yeah, hello. So let us look at part of descriptive data description and looking at statistical summary for categorical variable, okay? Yeah, so over here, what we are going to do is, again, if you go to the lecture 6, you'll be able to copy the codes and then learn along, okay? Now, so the data we are going to use here is the hints data. So what we are going to do here is, first of all, we are going to use this line of the code called the data, okay? So we have the read.csv, and then also choosing the data using, within this function, we have the choose.files, and then comma header equal true to be able to call the data that go into the location, a location on our computer, and then get the data. So now once you run that line, there will be this pop-up in which you are able to select the data. So there's the hints data. So I click it. Now the data is now active for you, and you can see it in the environment section. Okay. So now I can go ahead and run this line of code, looking at the names within the data, which is 17 column data. Okay. So I can also look at the first summary of the data set to see how the data looks like, the characteristics within the data. So there's the data summary, and then you can see that some of the data values have negatives. And this negative actually shows you some missing information or unwanted information within the data set, which has to be cleared before any further analysis. But before we proceed to clean that information we don't need for some of the variables, let us first of all attach the data so that we wouldn't have to always use the $sign to call a variable within the data set, okay? So let us attach the data. So now the data have been attached, okay? So once the data have been attached, let us go ahead and then run this line of code, which we are going to clean up the data by removing all the negatives, okay? So for these variables, quality of care, insurance, age, gender, full-time occupation, BMI, smokes status, then exercise, and then drinking per week, okay? So we have the data set, and with the square bracket, we use the concatenate function to group all the variables in which we would want to clean, okay? Introducing the sign, which is the end sign, showing that we want you to get rid of information within all these variables within the data set. Then within the square bracket, after we have closed the bracket, we bring comma after the bracket within the square bracket, whereby we are telling you, do this for the entire, columns within the data set. So in other words, for each row of these variables, okay, it is going to clear all rows that have any data that is less than 0, okay? And then now return all the columns in the data set. Okay, so let us run this line of code. Okay, so now we can run the head again. Again, we have all the variables within the data set because that's what we asked for, that retain all the columns within the data. And then also we can run the summary to see have the our cleaning be executed, and that is the answer is yes. The initial summary, we have negative here for quality of care, insurance, age, gender. But if you come here, you can see there are no more negatives, right? Those variables have been, those values have been taken care of as a result of the cleaning we did using this part of the code, okay? So now that the data is clean, we might want to still attach the new, remember we actually put it into a new data frame, right? So we might want to still attach the new data to ensure that we are able to use each of the variables within this data set without making use of the $ to call that variable, okay? So again, we attach it. Now, the reason why you are seeing all this red is because several data have been attached previously. And so at the end of the day, we can detach everything, okay? All right. So now we want to perform frequency using the freq function, okay? And the way you can use the freq function to perform a frequency for a categorical variable. Quality of care is a categorical variable of, I think, 5 levels, where the individual will ask about their quality of care, whether they have excellent, very good, fair or poor quality of care, right? Okay, so you have to first of all install this particular package, which is the summary tools, and then you then activate or load the package. Okay, I have already installed it, so let me just load that package. Then now I'm now going to use the freq function to be able to get the frequency of quality of care. Okay, so I can run it and then get, so this is the frequency of quality of care where I have the counts for each of the variables, for each of the levels of the variable, the valid percentages, the cumulative percentages, then the total percentages, and then total cumulative percentage, okay? So most of the time with the frequency distribution, we might want to actually, exclude, for instance, there is no NA in the data set. So this line of the table is what has no information. So we might want to exclude the NA. So within the freq function of the quality of care, we have report.NA. So we say false, which means we don't want the function, we don't want to report the any NA. And then also, we also don't want to report the cumulative frequency. So all what we want is to retain the frequency and then the percentages. Okay, so let's run that line of code. And so now here we have only the frequency and then the percentage, which is the counts for each of the categories and then the percentages. And then also the NA row have been eliminated. Okay. All right, so now let us also look at creating one-way table, okay? So you can use the table function to create a table, okay? So for instance, let's say we want to create a one-way table for quality of care. And the reason for creating a table is this is important, especially if you would want to develop something like, let's say, a bar chart or a pie chart, okay? So let us run this. So we are creating this new data frame for a table. So using the table function, and we are creating a table for quality of care. Okay, so now let us run it, and then let us run this line and see. So now we are able to see the quality of care in the form of table, the number of level 1, number of count, level 2, number of count, level 3, level 4, level 5. And remember, each of these levels represent a name, which is excellent, very good, fair, and poor healthcare, okay? Then also, we can also create this, a one-way table, but we can also create two-way table, okay? Where you have a column and then a row also representing different variable. So again, we are going to use the table function, but with that, within the table function, we are going to have two variables. So we are going to create a two-way table in which we have the quality of care as the row, and then the column being the gender, birth gender, okay? So let us go ahead and then run this line. And then let's go ahead and also run this line of the code. So you can see, so we have the quality of care as the row and then the birth gender as the column. And then, so we have the birth gender 1 and 2, 1 representing male, 2 representing female. So for instance, for a quality of care of 1, which is excellent quality of care, now we are able to know how many males have excellent quality of care? How many females have excellent quality of care? How many males have very good quality of care? How many females have very good quality of care? And then and so on and so forth to the fifth level of quality of care, which gives you the number of males that have poor quality of care and the number of females have poor quality of care. Okay. And that's how you can actually interpret it and then communicate this information if you have to interpret this table. Okay. Yeah. So in this now next, we can also be able to get some if we need some table totals. Okay. So how do we get a table total? So how do we come to know what is the total number of gender within, what is the total number of gender level 1, which is males? What is the total number of gender level 2, which is female? And then also, what is the total number of excellent quality of life for very good quality of life, good and then good. So we would want to have the table total for the rows and then the columns. So with that, we use a function called the add margins. So within the add margins, we are now going to put the two-way table we created from quality of care and gender. Okay, so let's run. So now we run it and then there's what. So if you want the total number of people with excellent quality of care, and that represents 863. But we know this represents for males, this represents for female, which is level 1, level 2, right? And then we are also able to know the total number for the second level of quality of care, the third level of quality of care, the fourth, and then the fifth. Now, in the same way, we're able to know the total number of gender level 1, which is representing males, and then gender level 2, which is representing females. And then also, this one represents the table totals, which is the entire total of the table. So in this case, we were dealing with the number of participants is representing 2,738, right? Okay, so now within this table, we can also decide to actually have some proportion, okay? We can have row proportion. So how do you include some row proportion? So we use a function called prop.table, okay, of our two-way, and then comma 1. Comma 1 here means we only want the proportion for the rows, okay? Let's run it. Okay, so now it changes from being counts to giving us the rows. So in other words, it takes the total number of rows and divide. So it divide each of the row counts by the total number of rows. Okay, each of the row counts. So for instance, here we have 340 being divided by 863. We have 523 being divided by 863, and that's what actually gives us this proportions, okay? And then we can also get the column proportion, and that's just by changing from 1 to what? From 1 to 2, okay? To be able to get only the column proportion. So you have prop.table function of our two-way table, comma 2, and that gives us the column proportion. Let's run. So now, with column proportion, it means the sum of the column, the sum of the rows of the column should give what? It should be equals to 1, okay? So in this case, if we sum up all this, okay? If we sum up this, that, and then that should be equals to 1, and that's a column proportion. So for a column proportion, it is taking each of the rows and dividing by the column total. Okay, so for column 1, it takes the first row of column 1 divided by the total, the second row of column 1 divided by the total, the third row of column 1 divided by column 1 total, and then that gives us this information. Okay, so now you can see that we have several decimals, right? But then maybe you don't need, you need only 2 decimal places. So if you need only 2 decimal places, all you have to do is to use the round function, round. So by using the round function, you put all this into the round function. Okay. So for instance, if we want for the row proportion, if you want to run it to 2 decimal place, we say we have round, then the entire function, okay, which is this one we have here. And then we are going to run it into 2 decimal place, okay? Let's run. So now we are able to get it into 2 decimal place. Now it's very clear, and you are able to know, it's clear to actually see. Next, you might want to actually change it to percentages. So to percentages and you still want to retain rounding it to 2 decimal place, okay? So with that, again, you maintain the round function. Then you just have to multiply the entire prop dot table for the row proportions, okay? You multiply it by 100. And then this 2 over here is within the round function, so round it to 2 decimal place, okay? So now we have them in what? It's in percentage. So we have 39.4%, 60.60%. So we have 41.95%, 48.05%, okay? And those are the rows in what? In percentages, okay? Now, similarly, you can also be able to add you can be able to get the totals, which is, let's say, the column totals, okay? The column totals or the row totals for each of the columns and rows you have, and that by using the add margin function, okay? So by using the add margin function, we are able to have a round the prop of the two-way table, which is the rows of the two-way table, are the proportions of the two-way table rounded to 2 decimal place, and then also give us the margin, which is the 2, which is the column totals, okay? So let us run it. Okay, so now we are going to have, so you can see now with this, we are able to have the margin. So it's able to add up each of the columns, and then this is the total for the column, okay? Column 1 plus column 2 is equals to 1. And then remember, it's because the proportions are generated based on the rows, okay? Then next, you can just have the prop.2a table, okay? Which is the table we generated for quality of care and birth gender. We can just have prop.table of that, and that is just going to be able to generate this information for us we did earlier on. And then by just using the margin, again, you are add dot margins of this prop dot table. Again, we are able to get the column and row totals, okay? Now we can, again, within that margin, we can now go ahead and then round it to 2 decimal place by also multiplying it by 100 to have percentages, okay? So now let us run it. Okay, so now we run it and we are able to, so you can see that, so there's the column 1 total percentage, column 2 total percentage, and column 1 plus column 2 percentage, which gives us 100%, okay? So in the same way, there's row 1 total percentage, row 2 total percentage, row 3 total percentage, row 4, row 5, and by summing them, it gives us what? Total of 100. Okay, all right. So now we also have what is called the three-way table, where you have 3 cross tab of 3 variables, 3 different variables, okay? So with that, we are not going to use the table function. We are going to use a function which is called the X table. So we have let's say we are going to assign it to three underscore table. That's what we are assigning it to. Again, this our assign function, and then we are going to use this function called x tabs. X tabs of what? We bring this function, which is called approximate function, and then we want the x tab of quality of care, health insurance, and then gender. And then the data in which we are actually going to take it from is what? The hints underscore new, which was our clean data. Okay. So within this function, you have to make sure you bring in the data so that the function can read the data and then to be able to extract these variables from the data to build a three-way table. Okay. So let's run this line of the code, and then let's run the next line to see the table. So now we are able to observe the table. So it is given us, so for gender 1, here is the quality of care for gender 1, and then another quality of care where here is the individual health insurance status. 1 is representing yes and 2 is representing no. So we are able to know for gender 1, for male gender, the different quality of care, and then for quality of care 1, how many people were in health insurance 1, how many people were in health insurance 2. The same way for gender 1, for quality of care 2, how many people were in health insurance 1, how many people were in health insurance 2. Okay, now for gender 2, we are able to read their quality of care for each of the insurance group. Okay, so for quality of care 1 for gender 2, we are able to know how many people have health insurance 1, have health insurance 2, how many people have health insurance 2, how many people of quality of care 2 and gender 2 have health insurance 2 and health 1 and health insurance 2, and so on and so forth. Okay. All right. So we can also use what is called the F table to be able to actually look at. So by looking at using the F table, now it is able to actually break them down for us to know for quality of care 1 and for health insurance 1. So for an individual who have a quality of care 1 with health insurance 1, this the number of male and then this the number of female. Okay. So for individual with quality of care 1, health insurance 2, there's the number of male, there's the number of female. For an individual with quality of care 2, health insurance 1, here's the number of male, here's the number of female. And for an individual with quality of care 2, and then health insurance 2, okay? Here is their number of male, number of female, and so on and so forth, okay? So that's how we can actually generate the three-way table. And then finally, we have what is called the C table, okay? The C table also allow you to be able to actually get a cross tab, okay? It produces a cross tab with some percentages for two categorical variable, okay? So for the C table function, you have X. X is representing the row where you use factor. Factor means you want R to notice that variable as a categorical variable, okay? So for the row, which is X equal factor of quality of care, and then Y, which is going to be the column variable, is called factor of what? Health insurance. So we want a cross tab of quality of care and health insurance, and using the C table function. Okay, let's look at what we get. And this even gives us a better information, okay, where we are able to know the percentages, the row percentages, and then even also we are able to also know the column percentages, right? So it gives us, so this for quality of care 1, and then we have for health insurance 1, okay, and then health insurance 2. So for quality of care 1, we have 845 people with health insurance 1, with 18 people with health insurance 2. Okay, And health insurance too is representing people without insurance. Health insurance has people with insurance. And this is the percentage. So out of the total of 863 people who have excellent quality of care, 845, which is representing 97.9%, has health insurance, and 18 of them, which is representing 2.1%, have no insurance. Okay, and that's how you also read it for the rest. And then also we also have another function within the C table function. Okay, so within the C table function, you can actually, if you want the proportion, you can actually tell R that you want to obtain the proportion from the table total. Okay, so within the function we have prop equal true. Okay, so now we are able to also get a proportion. Okay, so you can see how different from, so right here we were able, it was given to us the total percentages for the rows. Okay, but right here now we are able to obtain the proportion for each of the rows. So the proportion which is representing the entire total table. Okay, so for row 1, which is representing quality of care for those with insurance 1, insurance 2, the total is 863, and that is representing 31.5% of the entire total of what, 2,738. Okay, so that's how you can actually use the prop function to be able to generate the proportion for the table total. Okay, from the table total. Then we also, within the C table function, we can also have what is called a chi-square test, which is something we are going to learn in the future about how to perform some statistical inference. But however, with this, within the C table, we have what is called a chi-square. So by introducing the chi equal true, then we mean we want you to give us the chi-square statistic for this particular group. So if there are differences in the quality of care for the health insurance status, or if there are differences in the health insurance status based on the quality of care. Okay, so we would want to know whether there is a relationship between the quality of care and then the type of insurance the person is enrolled in. Okay, so we can run this line of the code, and then it can see that we have a p-value of 0. Okay, then with this p-value, which is approximately 0, it tells us that with that we can conclude that there's differences between there's a relationship between quality of care and then the insurance status, okay, or health insurance. But then again, there's a warning here which is saying that you have to be careful because the chi-square test may not be just may be incorrect. Okay, yeah. So we will learn in the future more about statistical inference, but there's how you can also generate a chi-square test from the C table. So I will see you in the future with more on descriptive statistics. Okay.